Realism is the sum of its parts. For the Sensory Environments Evaluation Project, we focused on those parts that contribute to the realistic feel of the scenario. The sights, the sounds, and even the smells that give things a believable quality. Those are the corroborative elements that are there in the real world. You miss them if they're not there in the virtual one as well. Things like the sound of footsteps, garbage in the streets, the sound of the trickling river, the train whistle in the distance, these are things that build up a realistic picture of a world that you actually feel you're in. Adding the emotional connection makes it seem incredibly real. Studies have shown that we remember things better when they have an emotional impact on us than things that are emotionally neutral. So if we really want to affect learning, we want to get that emotional realism in there as well.
In the scenario, everything needed to be moving. So when a truck drives overhead, rocks in the culvert break away, just like they would in the real world. Navigation through the world is also really important. There's a sensor attached to the head mount and trackers on the ceiling, which track the user's body movement through the scenario. There's a sensor on the head mount and trackers on the ceiling, which track the user's body movement through the theater. This means that when the user moves through the theater, the scenario reflects that movement.
Because of the inherent constraints of rendering in real time, we had to use creative techniques to achieve a realistic look. We start by thoroughly researching the environment we're trying to mimic, looking closely at references found on the web, in image libraries and films, and in the best case, visiting the actual location. We try to identify elements that define the essence of an environment, paying close attention to objects that evoke memories and tell a story. That's where we focus our modeling efforts and use a lot of our computer power. We're able to compensate for the faceted computer look of our low-resolution models by applying layers of photorealistic texture maps with built-in transparency. This is how we optimize our computer models to build convincing virtual environments.
The challenge with audio in a virtual environment is creating an immersive audio experience that mimics the subtleties of real-life acoustics. What we've done is place a listener inside a circular array of 12 loudspeakers and atop of a raised floor of low-frequency transducers, where the participant is literally surrounded by sound. During the demo, the coordinates of the sound effects and the participant are relayed to the immersive sound engine. The immersive sound engine then positions the sounds in real time over all 12 channels based on the orientation of the participant and the object's movements in space. The immersive sound engine actually models sound intensity in response to the participant's distance from an object. What this means is that as a participant moves closer to an object, the sound becomes louder. As he moves farther away, the sound becomes softer.
One of the details we really want to add is that of smell, because smell is one of the most evocative senses that the human being has. Smell affects us in a visceral way. It's a sense that is not cognitively processed. It's one that goes right to our limbic system, and we react to it before we even think about it. If we can put smell in these worlds, then they will be that much more believable and affect us more emotionally. For example, if we have a bad smell in the culvert, it may actually increase the anxiety that the trainee feels in the simulation. And then when you go outside the culvert and smell the fresh air and the river smells, that could put in a moment of calm reflection for the trainee. Our research efforts involve figuring out the best combination of senses to evoke a real emotional response, a real connection to the environment so that learning can be enhanced. Once we have this, we can figure out how this emotional response enhances the learning process. For the evaluation portion of the SEA project, we plan to wire people up with physiological monitors. This will give us feedback on heart rate, respiration, and other physiological metrics to determine where in the scenario we are getting the appropriate emotional responses. This will give us data to correlate where in the environment we are getting that physical and that emotional response. Once we know the users are responding emotionally to the environment, we can then start to study the effect that connection has on remembering what they've seen in the scenario. If we can succeed, we will dramatically increase the effectiveness of the experience learning system, not only for training now, but for all education in the future.